All right, let's see where we are. Lima.hawaii.edu. That's me. This. And, all right, so what I have done, let's see, today is we're starting, we're doing Chapter 10 today, and Chapter 10 is, you already know pretty much a lot of Chapter 10, but it's just summarizing the differences between SQL and, relational algebra, and how you can go back and forth. And so, and then starting on Wednesday, we're going to spend 2 weeks on normal forms, and I'm going to talk about the book talks about first, second, third, and BCNF, and I'll mention what fourth and fifth are because they're kind of interesting to me. But and then after that, we're going to just do some more SQL operators, but this should connect up with maybe your study.com, and then after we're done knowing about all the SQL operators, SQL is not a very complicated language, and so that's why we have time to go through all this other stuff. It just takes practice. After you learn all this stuff, it just takes practice, and there are those that hone the craft and become really good at it, and they can write these big, long SQL expressions, and it executes once, and it's done, and that kind of thing. And then transactions, and that's how we can make take a set of SQL instructions that we want to execute indivisibly, and how to do that, and some examples. And then I'd like you to come up with a project, and we can spend some time on a project. All right, so Chapter 10, let's see, do I have slides? I might not have slides. I guess I got to grab them on here or something. I'm going to save this in here. And this has all the slides for all the chapters. So I got to find Chapter 10. Oh boy. Good. All right. Sorry, I'm going to do something else. I'm going to do the PDF version. And same that, same place. Oh, I forgot. This does PDFs as that's okay. I haven't installed Adobe yet, but anyway, this is fine. Let's find Chapter 10. This is Chapter 8. So let's go down past Sql Operators. And now we're in Chapter 10. SQL Operators. Some addition. Oh, no, I'm sorry. What? Wait. Oh, this is mixed up. I guess, this is mixed up. I want to do SQL tables, don't I? Why is this different? Well, let me go to the book. Book's probably better anyway. Let me go back to here, and let me find the book. This one. Anyway, okay, let's go down to chapter 10. And what it is it's a summary, SQL tables. Okay, it's a summary of more or less what's different between SQL and it starts by telling you where SQL came from, where the name comes from. They call it SQL. They call it SQL. I mean, that's how we pronounce SQL. And it was implemented in IBM Research. That's IBM Research Labs or whatever. And there's a bunch of different versions. SQL in 1992, I believe that's what Microsoft Access. Microsoft Access, if you look underneath this SQL, if you're familiar with Microsoft Access, there's a window where you can click and see the SQL that's produced when you create your views and all that in Access. So there's these are the different parts of the standard, this command line interface, so on, basic concepts. So the properties of tables, when we think of them as relations, are, they never contain duplicate tuples. They can be unordered top to bottom. The attributes can be unordered left to right, and they're always normalized. However, an SQL table can contain duplicate rows. MySQL, you can have duplicate rows in there. So, I mean, a table can just store duplicate rows, and, there's no key, so, it just accepts it. And so it's up to you when you create the table, or after you create the table, to change it into a relation if that's what you want, which would be removing the duplicate rows. A relation is supposed to be unordered from top to bottom, but it kind of is. Yeah, it is, because if you just do a select on a table and you don't specify an order, it'll change. As you add records or take out records, when you just do a select, plain old select, when you notice when it comes out, it can change. Attributes unordered left to right. Well, in some sense they are, because when you're doing things like selecting or projecting, doing where expressions, you just specify attributes, and you cannot specify the third column or anything like that. So in that sense, they're unordered. However, there are plenty of SQL statements which do depend on the order. In fact, if you do an insert statement and you don't specify an order, or you don't specify the list of attributes that you're going to insert these values into, then there is an assumed order, and so you can just say insert this this tuple into the table, and the order of the attributes has to be in a specified order, and you can depend on that being in that order. And that means that if you get them out of order, then it messes up, and so that can be a source of errors. when you're doing inserting, especially if the fields you flip are the same type. And relations are not always normalized, because you can have you can have something like this, and this can mean either two things. This can mean either Blake does not have a status, or there's no, or we don't know what the status is. We inserted this record and we only had partial information, but we wanted to get it in there. We wanted to assign Blake an SNO, and we wanted to put in the city because we knew that, but we didn't have a status for that person yet. So this is something in MySQL. There's this null. You can a field can have an attribute of null, which means it hasn't been defined yet, and you cannot depend on null being anything when you're doing a where, other than you can test for it to be null or not. And so if there can be nulls in the status, and you want to list out all of all the suppliers with a status greater than 20, let's say, and you have a null field in there, the result is indeterminate. That Blake may be included or not. So you have to make sure in your where clause that you say status is not null and status greater than 20. You have to account for it. But sometimes it's helpful to have them. And this term relvars, as you can guess, that's only his term. If you go out someplace else and you want to talk about relvars, you can say, well, if you're familiar with date, he has this concept of a relvar, and then you can talk about relations being either the definition of a relation or an actual instance of a relation that has a value in time, that as opposed to like a literal. Okay, so we know that we're familiar with this sort of format for SQL. You might not be specifically familiar with it, but if you ever do an you have some tables in your MySQL, your PHP MyAdmin, you have SP and SP in there now, or something, suppliers, whatever. And if you should try to do an export and do an SQL export, and then look at the code that's produced, and you'll see this is a convenient format for insert, where you just specify the the fields like this, and then you can specify a bunch of values, and they'll all go in. This is very similar to this. This is the update in tutorial V. This is the update in SQL. It's misleading that it's on 3 lines. It doesn't have to be on 3 lines. It's not generally written on 3 lines. It's update SP, set this value to that where this is. So it's the same as this is the same syntax or semantics. This past the update keyword, update and the table name. You're specifying attributes that are going to take on new values and a where clause, so you can update more than one record if you want to in one statement. And this, for example, like if you leave this off, it'll update all of them. There's not really one big problem with SQL is there's not really an equality test. You can't test if 2 tables are equal. You have to go there. Later on, I'll give you an assignment where we sort of try to come up with this, if we were to actually write a solution to a problem using a procedural, like a programming language that supports relvars, how would you do it? Or pretend you're the compiler, and you're compiling a programming language that supports relvars into the actual SQL code. So it translates it, or it could compile, but translating is probably good enough. Interpreting, so a line at a time, you translate that into the one or more SQL statements that would be required to implement that assignment. It's usually assignments. It's assignments and then some sort of jumping. You have assignments, tests, and jumping, and you can do anything. So to do an equality, it's kind of tricky. There's SQL to generate the create table for a table. You have a table, and you want to export the table. MySQL has a facility where you say show create table and then the name of the table, and it outputs your create table statement for that table. And so you do that for the two tables, and then you can compare strings. Okay, so if those turn out correct, then you know that the type, the relvar type, is the same. And then after that, you have to compare each tuple somehow, one by one. But there's tricks. There's some kind of tricks you can do where you just compare certain things, and then you know that they must be equal. Kind of complicated. It's kind of fundamental, but that's kind of one bad thing. Not bad, but you don't do it very often. You don't have a table. Somebody gives you a table, and you want to see if it's the same, if it's equal to this old table already. Because if it's it's not very. You're almost always doing it on a record level. There's a tuple here. And if this tuple hasn't changed, then it's pretty easy to compare if two tuples are the same, but you still have to compare one field at a time. So this is a create table statement. This looks just like this is an SQL create table statement. Let's see if I can sign in, log in here. I'm at Manoa, is it? Noah.net. Something, nothing, okay. /cpanel. And I think I'm R1 CHARDH. HR 6. Is it percent pound exclamation point? I think so. Can't remember. Yeah. All right, is this the right one? Let's see. Sure. I hope it's the right one. Oh, let me look at. Oh, yeah, it is the right one. Okay, I wouldn't have supply parts in mine. All right, so I've got these three tables here, as you know, and we can just we can just export the whole thing and see what it looks like. Let's do a custom. All three of these tables. Let's just view the text. It's good enough. And blah, blah. Whatevs. Let's just go and see what this looks like. And here it is. This is a bunch of setup stuff, I guess. And I guess it does it as an entire transaction. So basically, because it doesn't want to be interrupted, it inserts. Yeah, okay, so it knows, okay, normally, there's a trigger. I put a trigger in here too. Oh, this exports the whole table. But at the very end, we add these constraints. Now normally, when you're creating a new database, you want to put start with empty tables, and then you want to put all the constraints in there, and then you want to start adding data, because you don't want to enter data which is going to cause the database to be incorrect once you hook up the constraints. Well, first of all, it won't let you hook up the constraints. Yeah, so that's why. So it doesn't let you hook up the constraints, and then you go, why doesn't it let you hook up the constraints? And you got to go through this process. Anyway, it's so. But when you're exporting a table, a database that we already know is correct, then it's a lot more efficient to load up the tables and then add the constraints at the end if you know that it'll work, because then it ends up because otherwise when you're loading up if you put the constraints in first and then you load in all the tuples or load in all the records, and let's say you got a lot of them, then it can take a really long time. Whereas it's faster. You want efficiency to matter. Anyway, so look, here's how you export triggers, and you can take this whole thing and take it over to you can take this whole thing. Don't do this. You take this whole thing, give it to your friend. Your friend takes it and just imports it in, and then your friend's got all your data. You get all your tables exactly the way they are. Quirks, little decisions on whether it should be varchar 20 or varchar 25 or something you miss, and that's how I check to see if you actually did that. Okay, there's so much stuff in there. Anyway, but I'm not here to. I'm going to assume that you're not going to cheat. I am here to tell you how to work efficiently when you're out in the real world and now. And being able to get a table from one database to another, or a database to one instance or one server to another, is something that you're going to have to learn how to do all the time. If you do databases a lot, you're also probably going to have to learn how to take a MySQL database and import it into a Microsoft SQL database. There's tools to help you, but they don't always work. Exporting a database from one server to another is something you can just search on Google, and it tells you right there. It's just about 3 or 4 steps, and that's it anyway. So it's not like I'm withholding any secrets from you. But when you look at these, there's the create table. See, so it generates the create table for you. So what I was going to show you was, let's go back to the database here, and let me go to SQL, and I can do show create. Can you see this? How do I make this bigger? Show create table P. I think that works. Where's it go? See the I gotta show full texts. Go and see, here it is. So so you can just get the result of a show create table and say that as a string, as a varchar or a text or something, and then you compare it with something else, and if it's exactly the same, I guess I wonder if the order of the fields though is going to be different. Wow, I didn't think of that, did I? I can't remember. I must have thought of it. I did something about that. You could always sort the, well, anyway, when I do the assignment, I will either specify that or I will have found a way around it. Anyway, so you can compare, so that's the the exporting of the table, but this SQL statement is always available to you. And then importing is, you save it out as a text file, and then you can just import it back in as a text file, and that's how you assign a table, or that's how you create a table. You create an instance of a table that's empty, so it's kind of like you're creating the header, and then you do the assignment into the already created variable rel var. So let me see. Where's the? Oh, okay. So that's create table. Table literals. It's like this would be a literal, which you could assign this literal value to the S table, the suppliers table, and then you've created the rel var exactly equal to what our database is, our table. Table assignments, table literal, table values, and then read-only operators, the where. A select is a read-only operator. You aren't writing anything. So these are some exercises here, but you should know the answers to these questions pretty easily by now. So the quiz, by the way, we're only going to spend one day on this chapter, so this is it. The quiz today, and I haven't finished the assignment yet. Today is officially the day that I was going to have this assignment one available. But I'm going to wait till the beginning of, we're going to start normalization on Wednesday, and I'll finish this. I need to put in the. I need to come up with the table, and I want to incorporate some fifth and fourth normal form stuff. Well, I'll have one that's important, and that's where I give you a table. I'll have a table that's just in first normal form. It's not in second normal form because there's some non-key attributes that are dependent on only part of the key, and then it's not in third normal form because there's some non-key attributes that are dependent upon each other, and so that's this big table, and it can be something like I don't know, names and addresses, and depending on their and then all you do is do a bunch of projections, and you store those projections into a table. So it'll be easy, and I'll go over it. And this is more of a, this is more of an enlightening assignment. You do the assignment, and then you're sort of, oh, that's that easy how to normalize. And when you're out in the real world, if you're, you may be not working on you might not be working in a big database project or be an SQL programmer, but you may instead be a programmer that has to incorporate a database or has to convert some sort of Excel spreadsheets and stuff into a database, and that's where you're really going to have to learn how to do it. I mean, this kind of thing will really save you, because you'll see this spreadsheet that's got a whole bunch of columns that are repeated. You see a bunch of fields that, this field only depends on this, and so it repeats a lot. And you'll see that kind of stuff, and it'll just be obvious where errors could occur. And then you will want to break it down into smaller, a bunch of smaller tables that you join together to produce this big spreadsheet, because your client is working with this big spreadsheet, and they want to see it in that format because they want to do stuff, or maybe they have a mail merge or something. They do something with this Excel spreadsheet, and what your job is to store the data in a database in a way that there won't be any like redundancies and errors and all that. But then you got to be able to produce that spreadsheet right back again. So that's kind of what this last thing is. So, but anyway, we'll get to that on Wednesday. But the quiz today is pretty simple. It is. So you got these. I couldn't figure out how to make the tables not have borders. Okay, I'm just amazed my CSS skills or something. But this is supposed to be like a program from here down to here, and this is one statement, and you know this is a declaration. We're declaring a variable called suppliers, and this is the type definition of it. It's the header. It's the header for this suppliers type. And here's another variable we're declaring. It's called shipments, and this is the header for it. And then there's another variable that we're declaring called shippers or suppliers shipping. Okay, and I want you to figure out what the header should be of that. But basically, it's this because the thing that executes down here is it takes suppliers matching shipments, which you know from last chapter or whatever, and that is being stored into this variable called supplier shipping, which is this variable here. See. So the first three, you're declaring 3 rel vars, and then this is an assignment statement. You're assigning suppliers this value, and here you're assigning shipments this value, and then we want to take suppliers matching shipments and store that into supplier shipping, which is the rel var you declared here. So that's this little program. It's just, I call it a pseudocode because it's not really, whatever. It's not really, but you get the idea. It's like a programming language. So so how would you so you have that, and you're the compiler, and you have to convert that into a series of SQL statements. Okay. Well, it's not that hard. I mean, first of all, you got to create table statement, and then you got another create table statement. You got a third create table statement, and then you have, an insert, with a bunch of values, 3 tuples, and then you have another insert that's got two tuples only, and then you have the last thing you have is something that looks like, and this is the part I got to tell you. I should probably put it in here because it's this MySQL insert select example. Stack Overflow. Okay, so here's a guy that says I want to be able to do this. It's not working. Oh, just because he wants to do that. Oh, I see. Sure. Anyway, the format is insert into something and then just the select statement. And the select statement should produce a tuple that will plug right into this defined tuple definition here. So it's simply I will put it here. No, here. I will edit this, and I will say for the last statement, use insert into supplier shipping, the thing that you got to do, select the thing, matching is, no, I got to find out what matching is. It's 2:15, this class, okay, it's time. Matching, where's the book? Does anybody remember what chapter that was? Have we covered that? We have, haven't we? It was not chapter 9, I think. Okay, let's go to chapter, where do we cover matchings? Anybody else in chapter 5, maybe? Oh, getting close. Ah, here we go. Oh, This is, oh, this is what it is. This is what it is. Well, it's, I don't need to, I should know that. It's just, where's mine? Here. Select, where am I writing it? Here. Select, S, I guess I'm just going to have to give it to you. S dot asterisk, no, you got to say what it is. Select from S natural join SP. Yeah, right. Yes. And this should be some sort of, what kind of font? Some sort of, this is a good font. Yeah. There. Nice. Okay. All right. All right. So, you know what I'm trying to say here? What is the header for suppliers matching shipments? You know what the header is? You know, when you're doing A matching B, you want the A records that are used in B or are matching. When you do S matching SP, you want the S records that have something in SP. Okay? So it's the S records you want. Okay, so anyway, so that tells you what the header of the supplier shipping is. And so that's what goes in here, you know, the attributes, and that's what goes in here. And what this statement does is this inserts into this the result of this. How, you know, this is going to be 0 or more tuples, and it's going to, this thing inserts it into this thing. And so that's what this is doing. Inserting this, whatever that is, it's a table. As a result, it's a bunch of records, and it inserts them, and we want to insert them into this thing. And this thing was just declared, so it should be empty, presumably. If you want to actually empty something, if you want to actually make sure it's empty, you can do that. When I make the key, I won't put that, but the way you do it is you just say delete asterisk, delete from table name, and that's it, because you aren't specifying a where. You just say delete from table, and then you're not saying a where, so that means everything. So that deletes everything from the table. But when you create a new table, it's created empty. So you can assume that it's initialized empty. So anyway, so this is an easy quiz, but the purpose of the quiz is to get you thinking, to continue thinking about how to do these, how to solve problems that involve tables, and you sort of think about them the way you would think about them using a programming language. And as I said, just speaking from experience, it has helped me become a lot more comfortable with writing complex SQL statements, where you have something and you want to say a table, like from a table, or you want to join a table with something. You can replace the table with another SQL expression, with another select expression, and that can be powerful sometimes. It's often not very efficient, so you have to check that, but test it. But sometimes you can avoid having to use PHP or some programming language, to actually create the thing that you want. We learned that if you learn SQL right along with the web programming language or the server-side scripting language or whatever it is that you're designing the web page for, you learn to do pretty simple SQL statements, and then you just create a table. You do an SQL thing, or you have a loop, and inside the loop, you have SQL statements inside a PHP, like a for loop or something, and so you're executing a whole bunch of SQL statements because you aren't savvy enough to figure out that you could actually do it in one SQL statement with some embedded SQL, and you don't have to have an outside loop do this. You can let the SQL engine decide because you've got a clever where clause or something. So anyway, that's kind of where this is headed, and this is kind of why we do this. All right, so I don't really have anything more. Any questions? All right, so I'll see you Wednesday. Did I press record? Yes, I did. Thanks for watching.